Hi guys, thanks for coming. Welcome everyone to Warsaw. This is a very special place, both for me because I'm based in Warsaw permanently, and also for the company, which was created in Warsaw, and we got the headquarters like 10 minutes walking away from this place, and most of the team is also based in Warsaw. So I'm going to tell you a bit more about oracles, like what is an oracle, what's our take on oracle, how we want to innovate this space. Is there a clicker? This is not the easiest team for the tech infrastructure, and we're also an infrastructure company, which means that there are a lot of challenges building a service. So for those of you who do not know what oracle is, or just to want to properly wake up after the yesterday party, I'm going to set up the scene and describe that an oracle is basically a service that helps blockchain apps to receive data from the external world, but also to receive any arbitrary piece of information that is necessary to properly function. So still the biggest use case is for lending protocols. So if you are allowing people to take out a loan against your collateral, it's important to properly price the collateral to avoid a situation that anyone runs out with more money that was deposited to a protocol. And an oracle usually takes data from multiple sources, like the off-chain APIs trust exchanges. Obviously, that's impossible to be done fully in the on-chain environment, so we need this intermediary. Getting that directly from APIs, it will be just a disaster for the blockchains that needs to synchronize across the nodes, and they need a deterministic execution environment. But also, if the data is already available on-chain, for example, if you want to directly query a DEX, that's often super risky. And we've seen like tons of hacks when the developers thought the data is already there. We just need to call a contract, take a price, and we're ready to go. But this price could be manipulated. It could be manipulated through a flash loan. We've seen it many times. Hundreds of millions dollars was extracted from protocols, but it could be even manipulated in a more sophisticated way, like a multi-block attack, etc. So this little piece in the middle helps us to protect all of the precious value locked in DeFi protocols. But there are some limitations that we notice in Oracle that we try to solve. Like the most common model for an oracle is to periodically update prices on-chain. So regardless if the price is used or not, there is a service that constantly pushes the information on-chain. And if it needs to do it constantly, then it's expensive. So the current way to reduce the cost was to limit the number of assets that we can provide price for. So then on the Ethereum mainnet, currently we got something like between like 100 to 200 assets that we provide prices for. And as you probably know, there are like tons of interesting things on the mainnet that we can have data about. So there are like derivatives, LP tokens, there are thousands of tokens, etc. So limiting access to that information prohibits the growth of the whole space. Also, if you are constantly pushing data on-chain, the intervals or the frequency at which we can push the information is limited by the high cost. So usual and optimistic update for the most frequent assets is around 10 minutes. And also there's an issue with the extending to other chains. So if there's a new chain, the whole infrastructure will need to be redeployed, the extra gas costs will need to be paid, etc. So it makes the expansion to a newly created chains, which are popping up like crazy recently, it's really tough. So we wanted to innovate the space, offering a very modular design for our oracles. So first on the left-hand side, you may see our data sources. And currently most of the oracles use the one that's presented on the bottom, which are the enterprise level aggregators or trading houses. So they already take the data, they certify the quality, and this data is being pushed on-chain. But we also expanded on that, allowing direct connection to all of the DEXs. And it's like really crucial if a token is not yet accepted by these enterprise-level aggregators or traders. It's just appeared recently. It's a very common case for all of the recently launched LST tokens, but it's traded on-chain with a decent liquidity. We can take data directly from there and deliver to customers. Also, we are directly connected to most of the centralized exchanges, and it cuts the middleman in the form of aggregators, so we can deliver the data faster, and also we get a much better overlook what's happening there, whether there's like a spread between bid and ask, or whether the volume of some of the exchanges drops. And all of these sources could be connected to our data provider nodes, which takes the role of taking the information from multiple sources and applying different aggregation logic. It could be simple median, it could be TWAP, it could be VWAP, or weighting based on liquidity, and also applies sanity checks, so we can verify if the price hasn't deviated too much in a short time span, so it's probably manipulated. So data providers are independent nodes. Currently we got more than 30 of them that are responsible for taking the data, sanitizing them, and certifying quality with a signature. And the same data packages are then broadcasted in our data distribution layer, which is a combination of a few technologies for the security, stability, and redundancy. So it ranges from, let's say, Web 2-like models when the data is distributed really fast, to a more decentralized approach with our open source lightweight nodes responsible for taking data package and broadcasting it to the neighbors. And we also utilize streamer network, a distributed PubSub network consistent of a few thousand nodes. So the data packages are highly available for anyone to grasp and consume in a target protocol. And there are also like 3 ways how you can consume the data. I am going to display that in details later. But what's crucial also in this slide is the connection between data consumers, protocols or dApps, and the data providers. So we do not enforce this connection. We allow a protocol to select a set of trusted data providers and only accept the information coming from them. And that's really important in a trend that we are seeing in DeFi. It's sometimes called like a bring your own oracle, or it gives freedom for DAOs to quickly spin off a new landing pool, or let's say a new product, when either a DAO or even a creator of this new pool can decide which providers they are going to use, and therefore it offers that much larger scalability for the whole ecosystem. So basically it's like with Uniswap, when anyone can create a pool, and then the liquidity may come. And we are seeing that in the future, with the lending protocols, anyone will be able to spin off a lending pool, select the trusted data providers, and then this pool may exist. So we are seeing that in, for example, working with Venus on BNB, working with Silo, or even Morpho recently announced there will be decentralizing the lending protocol to follow that path. So as I was explaining, in the middle there is this cloud called data distribution layer, which is a place when the packages are broadcasted, and it's not tied to any existing L1 or L2 network. It's a very abstract layer, and that's like super handy if you want to expand to new networks. So currently we are active on more than 30 networks. This is a screenshot of our page, which we call like a showroom.redstone.finance, and you can go there. We deployed a really tiny contract that takes the packages, extract the price, so we can test if it works on your network. By basically adding a new network that is EVM compatible, it's something like the 15 minutes of work just to test if everything is properly verified, and then we are ready to go. So that's really powerful if we are seeing especially recently, like solutions that are called like L2, on demand, or like with the Optimist stack and maybe with a ZK sync stack, when anyone can deploy their own L2 network, and we can be there in a matter of, let's say, minutes to deploy the necessary infrastructure. And apart from the EVMs, recently we also connected to a few known EVM chains, changing just the small part responsible for data verification. So we are active on Starknet, on Fuel, and recently we've been working with Ton, which are super excited because it's a network based on Telegram, and they are trying to bootstrap the DeFi also there. So going back to these three models of data consumption, the base one that is also utilized in all of the other models is something we call a core model. And in that case, so that's the flow of a transaction starting from user to a protocol, a user-initiated transaction. And then we bring from this data distribution layer assigned data packages that are automatically injected to a transaction. So it happens behind the scenes. From a user's perspective, it looks exactly the same as interacting with any other protocol or in a way that he's used to interact. It's just a single mouse click, single signature, etc. But there is like a more information attached to a call data. And this extra information, the price data, is then intercepted by our library that is connected to a protocol, verified. So we verify the signatures of data providers if these providers are the ones that were trusted by a protocol. And we obviously verify timestamp if the data is not too old. And then the information could be consumed directly from the call data and used in a protocol, for example, to accurately value the collateral. And it's also a very efficient process because we inject the information in the call data and we take it directly from call data for verification, having an additional single price feed costs an extra 15,000 gas. So it's like almost minimal for a user. It's less than a transfer. It's, I think, like a half of cost of transferring a token. So that's how it works in practice. As you may see, in MetaMask, a user sending a transaction, it's important that it's still a single transaction, can see these extra fancy hashes at the end of their message that after decryption are the information about prices. And the core model was an innovation in the ecosystem. And when we deployed that in January this year, we're like curious whether we'll adapt, or maybe it's like will be tough for the protocols to integrate, etc. And we are super happy to see that it works quite well in production. So there's like almost 60,000 transactions facilitated with the data being injected, as we detected on 3 chains that we currently are using the core model, which is Avalanche, Mainnet, Arbitrum, and more than $600 million were secured in transaction in the core model. But also when we started talking to let's say, larger, more established protocols, they are very used to the way how the oracles worked before. So they were expecting the information to be already present in the storage. And that's fine. You got a well-audited code, you've been working for a few years, and you are not so willing to take a new approach, to risk a new model until it's like proven successful. And for that use case, we took a step back and we offer a solution that is called Classic Model. So basically, we're like 100% compatible with Chainlink with a small addition of a relayer that is capable of taking all of the signed data packages and pushing it on-chain. But also what's interesting, this model is not like mirroring what was existing in oracles. It has much more flexibility. So anyone can spin off their own relayer. And you can decide on the terms, like whether that should be like a deviation threshold, heartbeat. Recently got a really interesting conversation with the options protocol that we're able to push price directly on the specific timestamp, which is not always easy, knowing how the blocks are mined, but they wanted that. And also, what's even more important, this relayer is something that could be easily replaced by anyone. So we got a trustless setup. If the relay is down, it haven't happened, but it may happen. I know if you got some real issues. Any of the users of the protocol can take the same data packages and act as a relayer. Anyone can be his own relayer, which is super important for the stability of Oracle's infrastructure. So relay is a passive system. Take signed packages, deliver it on-chain, following the same checks and verification as with our core model. We also got a third model, and this use case is really great for services that are extremely worried about front running. So with a traditional setup, there is a delay between prices being pushed on-chain. Even with the core model, when we update price feeds every 10 seconds, you still got a few seconds when a sophisticated user or hacker may know that the market moved within these few seconds and the protocol has got stale data. So the X model was designed to target this risk, and it works as follows. So when a user wants to make a trade and open a position, I think it's probably the best use case for perpetual protocols. So when a user wants to execute an action, this information, like the intention to execute an action, is stored on-chain. So let's imagine I want to open a long position on BTC. But the price at which this position should be settled is going to be delivered in the very next block, and is going to be sourced exactly at the moment when the user intention was mined on-chain. So there is no way to front-run the price, as the price is being discovered and delivered after the intention is recorded on-chain. So that's the model that was used in the GMX v1. We are now engaged in the discussion with GMX v2 as they want to decentralize their Oracle service. And it works quite well in practice. It protects perpetuals against front-running vulnerability. Also, what is interesting in, let's say, the stuff that we are working on and trying to improve in the Oracle space is the notion of the multi-dimensional price. So let's imagine there is a protocol, lending protocol, and it's got something like a 20 millions of a token that they're trying to have like a fair valuation of this collateral to allow other users to take loans. But it's a different use case. If I'm going to sell on the open market, let's say like a $1 value of a given token, and if I'm going to sell like $20 million value of a given token, there is a slippage. And for protocols to protect against that, there is usually a margin, like a 20%, that is allowed for a price to deviate or for liquidators to exit a position. But it's like a huge gap that when you are, let's say, like a winning a position, that actually quite quickly make composition of DeFi not very efficient. So what we are proposing is to provide in the real time a fair market valuation on a specific amount of tokens. So that's the value that you are going to get if you are at this point of time liquidating a given amount of tokens on the open market. So currently, we integrated with most of the DEXs, and we are combining the slippage across them, and we can draw a slippage profile for every asset. So a protocol can have a very accurate valuation of what's the value of the held assets. So also working in practice with many protocols, we learned that Oracle service is not just taking a data and delivering that to the target. There is a lot of stuff to be done in the middle to assure high quality of data. So first, obviously, we are detecting any outliers. So if one of the sources significantly diverge from the others, we are automatically excluding that on the data provider's level. Also, we are checking the volatility. So we got the data of the all of the historical volatility of all of the assets. And if you detect that, let's say in 5 minutes, it diverged more than in an hour, take into account that the full history for the last year, then we see there is something suspicious happening. And for the safety case, we can disconnect given source. Recently, we also introduced a slippage checks. So as we got the data about the slippage profile all over the assets, we can automatically disconnect a DEX when the slippage is increasing, which means that the liquidity probably moved to another DEX. And it's been done in the real time. So that's the protection against a situation when someone just moved the slippage, the liquidity, and want to manipulate the price to extract value from protocol. And that's not a theoretical case. If you look through what's happened recently in many protocols, there have been these kind of hacks. And often, when a hacker noticed that the price discovery mechanism pointing to one of the DEXs, most likely like to Uniswap, but also recently there was a lot of cases with the curve pulse, and when the slippage was diminishing, then obviously it's really easy to manipulate the price and then exploit protocols that relies on that price. Also, what we are doing is taking the referential price, and that's very important for all of the liquid stake tokens. So we know what should be the fundamental price of an asset, and if it diverges a lot, we can disconnect a source that is providing us with an incorrect value. I've been focusing mostly on the DeFi data because that's still, let's say, the majority of use cases for oracles, but we also open a service that will allows anyone to create their lightweight oracles for any kind of data. And we got it out for public. And from time to time, I'm looking like what's going to be built there. So yesterday, for example, I discovered that someone connected the data about the altitude of the International Space Station. I got absolutely no idea where the data is being used. But in our system, you can simply point to a given API, and there are like multiple nodes fetching information from that and making it available on chain. So if you are hacking, or if you want to build your custom oracle for the data sources that are available in the Web2, but you do not know how to plug in this infrastructure to Web3, we offer this service. We call it custom oracles. It's like offered for free for experimentation. As I mentioned, we're based in Warsaw, and last ETHWarsaw, we've spoken with a lot of people, and we got these 3 amazing folks, brilliant guys, that actually met us during the last ETHWarsaw. So if you're looking for a new opportunity in your life, if you want to start a new journey in Web3, come to our booth, talk to us, and I think that there's really amazing people, great crowd in here, and we'd love to meet you, and maybe, possibly, probably work together because we solve interesting tasks, and it's just fun to work with us as we got a really cool team of 20 people here in Warsaw. So just to recap, why should you use Redstone if there are so many different oracle providers? So a first reason that I often hear from the customers is the fact that we offer feeds for assets that are not available anywhere else. So there are like newly created tokens. These are the LSTs. We've recently are integrated with a few of them. There are LP tokens that are used right now by these protocols that are making investment into LPs, especially for Uniswap v3, much easier. And they need proper pricing for the LP tokens. They're the real-world assets. And we started providing prices for T-bills, obviously, but apart from that, also for European bills and ETFs. And there are derivatives of different kinds, like stake tokens or protocol tokens that are available on chain. So thanks to the fact that we can connect directly to DEXs, we can provide prices for all of them. We also offer this information at a very low latency. So at default, we work at 10-second latency, but if necessary, and if you are considering like a really widely traded assets, we can get down to less than 1 second of the latency, and the update interval. Also, as I mentioned, we got a lot of security checks. So oracles are quite easy to be built if everything is stable, if everything works fine. But during last year, we got a few scenarios with the depth of USDC, with the curve drama, etc. And as all of the data is being available on-chain, you can detect and check that we work really stable and there were no issues with our infrastructure. As I mentioned, also the fact that we abstracted data broadcasting and publication, our decentralized data distribution layer, makes it super easy to deploy the service to a newly created chain. So if there is a new chain that you would like to expand, and there are a lot of super interesting ideas like Base, Mantle, Linear, when we are already present and working with protocols, and if there's just a chain that was created a few days ago, you can get to us and you can start providing the information as fast as possible. And we are very flexible, so we own not only the data discovery process, but also we are very engaged in the data aggregation methodology. And we got multiple ways to push the data to the on-chain world. So if there's like a very specific use case that you want to work with, we are a small, nimble team, and we can accommodate to your needs with a tailored solution. So that's all. It was about Redstone. If you got more questions, we are available downstairs when you get a boot, and I'm also going to be available after this presentation. Hope you enjoy it and have a great launch. And